Hey guys, are there any questions on any of the assignments thus far? Any questions over any of the assignments that we have done thus far? On any of the homework? Right. Need a note sheet for today. Now what we're doing today is we're looking at systems of equations in 3 variables. Yeah, as we're starting a new section today. Logan, I need to stop. Okay. Put that away. And here's another one. Now, when we look at solving systems of equations with 3 variables, there's going to be a solution of the ordered triplet x, y, z, or a line or equation that works. So this here is an example of a system of 3 linear equations. So we're going to have 3 with 3 variables, and the goal is to find the solution for this here. Now there's different setups or different solutions we can have. Now the first one is going to be that we have exactly one solution. We have exactly one point that all 3 intersect at, that all 3 cross at. And if we find that point there will be the solution for this system of equations. And we'd have exactly one, because again, we're looking to where a point is going to satisfy all 3 equations. Where we plug those numbers back in, it will make the 3 equations true. Now the next one that we can have is an infinite number of solutions, infinitely many. And this equation here, or the equation that defines this line, would be that solution. Because any point on that line will make all 3 equations true. If we plugged it back in, we would get the same thing on both sides. It would give us a true statement. And the last one we have is no solution. No solution means that there's no point of intersection between all 3. Because if we look at the first one, these 2 here do cross at these points, but not all 3. And the same is true for these here. We don't have a point where all 3 cross, where all 3 intersect, where all 3 equations would be true. The same is true for this here, because at these 2 lines, we only have 2 of those planes intersecting. We need all 3. And the last one, well, there is no intersection at all, because the 3 of them are parallel to each other. We need them to have at least one point in common with all 3 planes. That is the main goal for this here. Questions on this so far? Now this is already in your note sheet, because these are the main steps, bless you, that we will be using to solve this here. Now it says the first main step is to rewrite the linear system in 3 variables as a linear system in 2 variables by using substitution or elimination. Solve the new linear systems for both its variables. Substitute the variables found in step 2 into the one of the original equations, and solve for the remaining variables. Now, at some point in any part of this, if we get 0 equals 0, the bottom one, a true statement, because 0 is always equal to 0, then we have infinitely many solutions. If we obtain a false statement, 0 equals 1, then it's going to be no solution. Okay? Now, a better way to look at this, so our first kind of steps, and we can write these in, is we want to pick a variable to eliminate, that we want to eliminate out. And an equation to eliminate it with. Yes.
I seen you at Walmart yesterday.
You did?
Yeah. Actually, I didn't really see the car. I seen it back. I mean, I didn't care because I was like, this is Mr. Flynn. I thought about honking at you, but I'm not
Now, the second step, guys. Logan, I'll take that pen. No, I'm not. Logan, I'm not looking at you. So we need to pick an equation, a variable to be eliminated, and an equation to do it. Now our second main step is to eliminate that variable. We want to eliminate that variable out of the other two equations. And guys, so what we're doing is we're taking three equations with three variables and bringing it down to two equations with two. Our third step is going to be to pick another variable to eliminate. And eliminate it. And the last step is to solve. Bless you. Guys.
sorry. That's a trick shot.
Do we have these steps down? Okay. Let's look at the first example problem. So this here, we're wanting to solve this system of equations. And the first main step is we want to pick one variable to eliminate and an equation to do it with. Now when we look at these here, we're wanting to see which of these sets of variables will it be easy to make be the other two. Because if we look at the y's, specifically, y by itself, I can turn this into 3y or 2y. Because if I multiply y by 2, I get 2y. If I multiply y by 3y, I get 3y. So we can change those easily. We could have also done it with x. Because it'd be easy to turn 2x into 4x because I can multiply it by 2. Or we can turn 2x into 6x by multiplying it by 3. And that's really what we're looking for, is to see which variable can I turn one of those three into, the other two easily. Now z, even if we pick the smallest one, because we're only going to want to increase these, is it easy to turn 3 into 5? No, how about 3 into 4? Well, no, we can't just multiply it by a nice number and get those. So the first variable that we would want to eliminate would be either x or y. Which one do we want to eliminate first? So we can do y for this one here, but we'll get down to the same answer. We need to pick just one to do this with. So we picked y, so we're going to have to get them all be the same, all the y values to be the same. So we need an equation to eliminate it with. And the equation we pick is the one that contains that variable that we can change the other two into easily. Because for y, guys, for 1y, I can change it into 2 and 3y easily. Because I can multiply the y by 2 to get 2y, or I can multiply it by 3 to get 3y easily. I can do that. So we pick this equation to eliminate the other two out with. So we pick the equation that we want to eliminate, or use to eliminate, the bottom one, and we pick the variable y. Now, we're going to rewrite the other two kind of in the center. I would write them in the center of your note sheet and make sure we have room because we'll need a little bit of space for this. And out to the side for where we're going to work it. Because again, are the three y's in these three equations the exact same? No, so we're going to need some space to work with it so I can change the eliminator equations y to be the same as the other two. So the first one, we'll have 4x plus 2y plus 3z equals 12. And we'll also have 2x minus 3y plus 5z equals -7. Because those are the two we're going to eliminate the variable out of. We're using the other one to eliminate it with.
-2, 4, 3, 2, and 3, 5.
Any questions on this here so far? Now, I'm going to move this over. You don't have to move it over. I'm just moving it over so I have space to write on the sides.
Hey, how did we just move it over?
Yeah, it would be, but
We can't just,
yeah, unfortunately, you can't just do that. Now, for the first one here, we need to get this y to be the same as what? 2y, yes? So what can we do? What can I do to y to make it be the same as 2y? We can multiply it by 2. So what we're going to do is we're going to multiply the whole equation. Both sides, we're going to multiply it by 2 so that we get the y's the same so that we can eliminate them out. And at this point, we're going to distribute. So we'll do 2 times 6x is 12x. 2 times negative y is negative. And 2 times 4z is going to be plus 8z. And what we do to one side, we have to do to the other. So we still have to do 2 times -3 is -6. Any questions on anything we've done so far or how we got this equation rewritten? So what we can do is we can put it right underneath this one here. Any questions on this here? Now, here, we do have the y values the same, so we're going to be able to eliminate those. So do y'all have this written down? We're good? Y'all are all caught up to this point, yes? That's the case, because, yeah, make things work a little bit easier. I'm moving it over here because I believe most of y'all have space on either side for each one so that we can kind of keep it organized. Now on the other side, we need to get this 6x minus y minus y plus 4z equals -3. Now we need to get this to be the same as what? We need this y to become what? Which is 3. So what do we need to do to this equation? 3. So we need to multiply both sides by 3. So that we get the y's to have the same value. Bless you. So we'll distribute through just like we did with the other one. So 3 times 6 is 18. 3 times negative y is going to be negative. And 3 times positive 4z is going to be plus. Z is equal to 3 times negative 3 is. So again, we multiplied them all by 3, both sides, so that the y's will have the same value. And once we do this, we can put it underneath. So 18x minus 3y plus 12z equals negative 9. And again, the whole goal for this first step is to take it from 3 equations with 3 variables to 2 equations with 2. Any questions on any of this here? Are we ready for the next step? Now, to eliminate the variable out, we're going to either add these 2 equations together or subtract them from each other. We're either going to add them together or subtract them from each other. And the variable that we chose to eliminate was y. So we need these 2 to cancel out completely, and we'll need these 2 to cancel out completely. Yes, sir. You have your card?
I do not have my card because I haven't got it finished from him. I asked him about it yesterday. He said that he would give it to me after the drug test.
Okay, we'll address that in a little bit. Now, we'll look at this one here. So 2y and negative 2y. We want those to cancel out. We want them to become what? 0. So would I add these 2 together or subtract them? So if we subtract, because 2 minus negative 2, the negative and negative to make a. So we'd have 2 plus 2, which is 4. It's not 0. So we wouldn't subtract, we would add, because 2 plus negative 2 is 0, because it's the same as 2 minus 2. So those would cancel, yes? Which means we're going to add these 2 together. Because if the signs of what we want to eliminate are opposite, we add. If the signs are the same, we subtract. For this here. If the signs are the same, we subtract. If the signs are opposite, we add. Yeah, he'll mainly stay to the lights. So, Anthony, let's leave it alone. So, for this, guys, focus back up here. Focus back up here. Yep, so we'll add. So we'll do 4x plus 12x. 4 plus 12 is 16x. Now 2 plus negative 2, or 2 minus 2 is 0. And 3 plus 8 is 11. So we have plus 11z is equal to. Then we have on the other side, yep, 12 plus negative 6, or 12 minus 6 is 6. So we took those 2 equations that both had 3 variables now to one equation with 2. We got rid of one variable. Now if we look at the other one, so if we add these 2 here, negative 3 plus negative 3 is, well, a negative plus a negative gives us a bigger negative. So negative 3 plus negative 3, so we can say negative 3 plus negative 3
That'd be negative 6.
would give us negative 6. So if the signs are the same, we don't add, we subtract.
I thought a negative made a positive.
So when we subtract, so Tyler, because here the negative and negative would make a, so the negative 3 plus 3 is 0, just like we want it. Now 2x minus 18x, 2 minus 18 is x. Now the negative 3 plus 3, guys, is going to be 0. We'll move on to the next one. 5z minus 12z. 5 minus 12 is z is equal to. So we have negative 7 minus negative 9. Well, the negative and negative plus. As we have negative 7 plus 9, or 9 minus 7, which is 2. So what we've done so far is we've taken 3 equations with 3 variables and turned it into 2 equations with 2. Essentially what we're going to do next is do the same thing again. We're wanting to get rid of one more. Because no matter what we've done in geometry, algebra 1 here, 8th grade math, 7th grade, 6, going back, there's not been a time where we solve for more than one variable at a time. Because in geometry, we had some where we solved for 2, but in order to solve for 2, we had to find the value of one of them first, and then plug it back into the other to find it. We couldn't solve for 2 simultaneously. So, any questions on this here? So looking at these 2 equations here, do we want to eliminate x or z next? Why x? Right, we've got 16 and 16 in front of both of them. They're already the same. Because if we eliminate one and one of the other ones match up at this point, let's eliminate it next. So we can rewrite it as 16x plus 11z equals 6 over negative 16x minus 7z equals 2. Are the signs the same or opposite? If the signs are opposite, we will and one of the easiest ways to make sure that you got the sign correct is see which one we're trying to eliminate and actually do the calculation. Because I can type in 16 plus negative 16 in a calculator. If we get 0, we have it right. If we get something that's not 0, okay, we did the wrong sign. Because 16 plus negative 16, or 16 minus 16, is indeed 0. So they cancel out. 11 plus negative 7, or 11 minus 7 is z is equal to. So we've taken it from 3 equations with 3 variables to 2 equations with 2 variables. Now we have 1 equation with solve. Because we would divide both sides by 4. Telling us z is equal to 2. Now how many variables did we start with? 3. We had x, y, z, yes? We still need to find the values of y and z. But to find y and z is not as bad as you might think. Now, if we go back up the equation, here I have 2 equations that are in that have x and z, yes? Do I know one of those 2? We know what z is, yes? So which one do we want to use? It doesn't matter. So if I pick this one here, we have 16x, because we still don't know what x is, plus 11 times z. Well, z is what? Now we just need to solve for x. (11 times 2 is? We would? Minus 22 from both sides, yes. If 22 minus 22 is 0, telling us 16x. 6 minus 22 is negative. So we can divide both sides by. Telling x is. So we have x and z. What are we missing? So that's the only one we have to find next. So everybody's to this point? X is -1, Z is 2. Pick one of these three. So we would have 2 times X. Well, X is -1. Yeah, we need to find the value of all three.
That's right.
Minus 3y plus 5 times 2, -7. -3y. Well, -2 plus 10 is? Which will tell us that -3y is equal to 7 7's 14. So one more. And last but not least, minus y is equal to, so -1, 5, and is the solution. It is the point that all three of these planes cross. Questions on this here? Now, if we plug these back into any one of these equations, we plug these 3 points in, we would get a true statement. It would be indeed true. I'm assuming y'all have all finished solving this one here. Okay, one more time. So if, like the bottom equation, we plugged in this here, we said 6 times -1 minus 5 plus 4 times 2. And we work this out, we'll get -3. Because 6 times -1 is -6. Minus 5 plus 4 times 2 is 8. -6 minus 5 is -11 plus 8. And -11 plus 8 is -3, because we said it should equal -3. And if we plug these three numbers in for x, y, and z for any of these equations, we'll get a true statement. Both sides will be the same. And really, that's what we're looking for. We're looking for the point or equation that all three equations will be the same.